We're live. Hi everyone, welcome to our new episode of Building Humanoid Robots. Again, I'm Elaine, Head of AI Robotics at Seed. In the very beginning video, that is a kscale M-bot simulated working, and that is collaborated with RobStride Dynamics. I'm super excited, invited Shawn,
Hi.
founder of RobStride Dynamics, and one project director at RobStride, and join our live stream and talk about their expertise, actuators for humanoid robots, and also the entire back of the humanoid robot. Last time we had a great live stream together with kscale, also their partner, and working together for different robots. And we introduced the keyboard that is using RobStride actuators and also our AGX Orin robot. So this time we will introduce this smaller and cutier. It's called M-bot that is developed and created by kscale Labs. So welcome, Shawn and Wang.
Hi, so I'm Shawn, and this is Juan. So we are RobStride Dynamics, a company dedicated to the development of integrated robot actuators and their ecological products. So currently, as a globally leading company capable of mass producing integrated actuators, our products have been sold in more than 20 countries worldwide, I think. Moreover, we have collaborated with many international world famous universities such as UC Berkeley and USC and Duke University and even Stanford and so on. Yeah.
That is amazing, Shawn. So yourself and your team worked for Xiaomi
Yeah.
before, and you also lead project of Super Gear
Yes.
and also Super Dog series. So you have tons of experience for building robots from 0 to 1, from the
Yeah.
scratch. And also you have been worked through a lot of development issues
Yeah.
and encountered the different difficulties when you're working with different type of the companies, I mean humanoid, also other robot type. So I want to know what is your current takeaways when you're seeing so many humanoid robots and you're working with them.
Okay, so as we have worked and cooperated with so many robot companies and including many open source projects, we found that companies like Unitrees many target research institutions and start companies, but there are no many robots serve individual developers around the world. So I think the development progress will be much faster and more efficient when work is done in the open. So when kscale Lab talked with us with their targets, I think this will be a very good collaboration. Yeah. So therefore, in collaboration with Seed Studio guys and kscale Lab, based on our integrated actuators, Seed Studio computing system, and kscale Labs software platform and hardware design. We are working together for open source and faster this progress. Yeah.
Yes, indeed, I truly agree. We have been live streamed many times with kscale, and also last time when we review back the GTC, we found that especially for humanoid development, there is no standard yet. So the open source, we need the open source to and working with the researchers and communities and to foster this progress. And also kscale have built their open source humanoid stack with affordable humanoid robots and reinforcement learning, VLA models, and also they include the AOS for sim to real pipeline, which means that for everyone can build on that. Yeah, so they built an entire robot stack from the ground up, hardware, software, machine learning infrastructure, and they updated many versions of the robots starting from last year. And especially this week, they have a very big announcement for their keyboard. And so it can be pre-ordered worldwide right now. And yeah, so check out kscale website for more information. And today we're excited to showcase kscale's the other one, M-Bolt. So it's very compact, and it's just a 0.7 meter tall, and use the QDD actuator for reinforcement learning, research, and experiment.
Yeah. So as you can see, this M-Bot is a very initial version. And besides, I would like individually thank a guy named Yufeng Chi, who is a very brilliant PhD student in like hybrid robotics group, like from UC Berkeley, who helped us to understanding more about the humanoid and more about the reinforcement learning. So he helped us a lot between the collaboration with between us and kscale. Yeah.
Yeah, so I mean, the humanoid robot needs a lot of power from the research organizations. So we're also very actively working with academics, because apparently all new algorithms are coming from the cool academics.
Yeah.
Yeah. So let's take a closer look at this open source humanoid robots. Very cute. It's not very tall. Frank, please zoom.
Okay.
Let's see it here.
Yeah.
Okay, we
It's
see
very
there.
lovely. Yeah.
Yeah. So the key components is apparently is compromise of actuators, and Shawn, tell us more about its height. Its height as a weight and the head. I see you leave some freedom of that, and also what is the heart of the computing system as a controller,
Okay.
etc.
So as you can see, this lovely guy is named like M-Bot, is a very latest robot of kscale labs. And of course, this is a very initial version. So and we are now working more to modify this design. So as you can see, this robot has 20 DOF, which means there are 20 actuators inside this robot. But there are no actuators, means no DOF neck and wrist. And for each leg and each arm, there are 5 actuators each. So which can ensure basic movement for like very like a real human being. And for the head, now there are nothing on the face. But maybe later we will add a screen or add like some sensors such as cameras or other sensors on the head. And inside the body, there are 3 components. For one is this C Studio like recomputing center, and 2 is like our CAN hub, like this our CAN hub, and 3 is our actuators. So is a power management. Sorry. So for the power management, including power board and battery, of course. So these are all components inside the body. Yeah, that's all. And by the way, so all the structure parts supports like the 3D printing. So I believe all the individual developers, when they get the diagram, they can DIY their own robots. Yeah.
Yeah. And also like in the for the M-Bolt hat, we can add more emotional reactions put on the screen, and add AI, RGB camera, or a depth camera for enable like more navigation.
Yeah.
Yeah. Great. So let's thank you, Shawn. So let's take a more closer look like for the inside of the M-Bolt, and see how the hardware what is the exact hardware connected with each other.
Okay, for this, maybe one can help us to introduce. Yeah.
Hello everyone. Our robot uses CD computer mini as the central controller. and it connects the MU and can hub by this USB and connect the screen located on the head where you are. This green one is our CAN hub, which integrates a USB hub and 5 CAN ports. 5 CAN ports converted by Cannonball V1 Pro.
Go on.
Allowing us to control 5 CAN buttons with one USB interface. 4 of them are respectively connected to the left and right arms and legs. And the last one is connected to our power board to control the input and the output for all power supplies and the batteries on the entire body.
Okay, that's all. So I think I will give you guys a very simple like summary. So our considering like two integrated like development, so we use a CAN hub. Our CAN hub designed by ourselves to help to like integrated all the CAN bus in one USB, right? So connected to the like rig computer center. This would be much easier for wire design. Yeah.
So this can help in my hands. So that is RobStride. They designed for. So there is 2 CAN bus on our rig computer mini, but usually for bipedal this is enough. For the humanoid, the 2 CAN sometimes will be not enough. That is, developers can using this converter board for using the USB and then convert to CAN, right? And also it runs stable.
Yeah. Yes.
Okay. And so besides the power board, besides the actuators, this extension board, you also provide the power. You also provide the power board.
Yeah.
Oh, 1 second. I just realized I didn't show this hub because I didn't change the screen. Frank, can you zoom in again for this? Yeah. So this is the CAN hub. So how many? How many cans in total it can be converted?
Okay, so on this board we integrated 5 CAN bus. So you can for each CAN bus can connect at maybe 6 actuators at most.
Okay, so it will be 30 actuators.
Yeah, will be 30.
I have a question. So if I use the need one USB, USB 2.0 can be enough, right? So if I use one USB so I still have more to the CAN bus on the device. I can still use this.
Yes.
For XT30 interfaces.
Yes. So actually, of course, you can connect CAN bus directly to this recomputing center. But considering the wire design and for the easily development of robots, and so that's why we designed this CAN bus.
Okay. So but this is only used by wiring.
Yes.
This one is only used the wiring.
Like so you can imagine that if you just use CAN bus to connect to this recomputing center, you need like at least 5 combines of CAN wires. So this will be a very, very complex system. But for now, you just need one USB port connected to here. This would be easier.
Okay, great. Thank you, Shawn. So a quick recap of MBOT. So first, the software is powered by the kscale platform, and so software, hardware are open source, and so including schematics, structures and also upper level control algorithm we will introduce later, and also lower level embedded algorithms. And also all the structure is 3D printable, or that is friendly to developers. And all actuators are from RobStride, the series that is you can find from RobStride websites. Yeah, so Shawn, let's close take a look at these 20 actuators of MBOT. So that is all. You're also including some of your new actuators. Yeah, just a release and fresh release.
Yes.
Even no any documents. At least they just bring that today. Yeah. So let's firstly take a look at each different each actuators of their each model, and then let's closely take a look of your new actuators.
Yeah, maybe one can help introduce this.
Hello. The following is our activator configuration table for each joint. We mainly use 4 types of activators on this robot: RSOO, RSO2, RSO3 mini, and RSO mini. For the hip and knee joint that bears the greatest force, we use RSO3 mini with 35 millimeters, Newton meters circle, and for other joint, we mainly use RSO2 and RSO by their different surface and pipe by their different force. And we use RSO mini on shoulder and wrist yaw axis because the surface limit because the surface lattice.
Finish. Okay, so quick conclusion. Yeah, again. So as you can see, like we use 4 types of RobStride actuators on this board, and even on keyboard we use other 4 types of actuators of our RobStride actuators. And considering like robots need a very powerful movement ability, so we use like as big as possible. So that's why we use O3 Mini, which can reach like 35 newton. So that's why we use them on knees and hips. And then considering like beautiful or kind of things, we use smaller actuators on arms and other position of legs. So that's why we choose these 4 types of RobStride actuators. And even for the most expensive one, for O3 Mini, about 35 newton is only about like $200. Yeah.
Mm-hmm. Yeah. So the last two column is the price in the Chinese yuan $4 is around divided by 7. So I can see your 5 newton is from my math is like $70, and to the 35 is like $110.
Oh, actually, we cannot easily calculate like that. So,
I hope that.
Considering the shipment and insurance, so the USD price would be a little bit higher than the RMB price.
Including
including the shipment and insurance. Since since we provide DDP for individual buyers, and we provide DEP for B2B like customers.
Okay, so for if you want to buy the actuators, and just go to your website.
Yeah.
Okay, and also I haven't very closely looked inside the architecture of the actuators. We have a video,
video.
introduce your introduce of your actuators. Okay, here we go. So can we have a can you explain the architecture of what is the compromise for one actuator?
Okay, so for nowadays, like when the requirement of a robot get higher and higher, so which means like we have to make the actuators more integrated. Yeah, this is like a new requirement of humanoid. So that's why we integrated like a reducer, motor, and encoders and drivers all 4-in-1. So we use like all dual encoders in our actuators, and we use planetary reducers, and we use like motors. So these all 4 parts are getting in one, as you can see in the video. And for our driver, like in our driver algorithms, like we for now for communication protocol, we support like standard CAN and CAN open, and maybe later in the future we will support KFD as well. And to help more and more like friends to use our actuators. For now, we are developing more switch modules such as CAN to either CAT or any kind of things. Yeah.
Okay, so your actuators can connect to more hardware that with the different interfaces.
Yeah.
Okay.
Oh, by the way, so for our standard products, it's about Canvas. And if you want like CAN open or some other communication protocol, you can go to our GitHub and get some like support. Yeah.
Great, thank you, Shawn. So for the M-bolt part, you are using Ray Computer Mini. Actually, you developed this in very fast, like less than 1 month, for that you integrated Ray Computer Mini into the body. So I want to know. At first, we choose Ray Computer Mini. We recommend that because it's very compact and also including all the interfaces. I want to know how is your current experience with that?
Okay, this is like a story. So when we were designing robots like humanoid or cyberdog in Xiaomi, so we get NVIDIA GPU, and then we have to design other like other PCB ourselves to to integrate like USB internet port or the CAN bus together, and then we need to design this like we call box. But now when we see this like we computing center, it's small but more integrated. So we don't have to design other things. We just need to design this CAN hub and our power management. Then we can use this to design the entire robot. For this is one more integrated, and the two is quite small. Yeah, it's very fit for such a small robot. And even I think maybe for smaller robot, this would be fit as well. So I think maybe later in the future we can design a smaller robot together with kscale. And then for 3, like you see, you have integrated all the ports we need on this box. So enough. And most important, the AI performance. So we say like computing power. Is totally enough for such a humanoid.
For running for deploying the AI models. It is they are using a Ray Computer Mini model of the J4012 that is powered by our Orin X16. So the AI performance is up to 100 TOPS AI performance. And Shawn, so it is very compact and it's inside of M-bolt. I want to know how is the heat dissipation? Is this mixed because this temperature range is up to 50 Celsius? So is this meet your requirements? How is that working when you operate? You operate?
So when we design the hardware, especially the structure part, like there's a kind of design called wind tunnel. Yeah. When the fan works, this will be very hot, and this will be very hot
because
inside.
It's closed.
It's a closed space. So we design a wind tunnel from right side to the left side. Then the wind can go through the entire body to get this hot wind outside the robot to keep the robot body inside reach we call the heat balance. Right. When the temperature reached heat balance, the computing center, the power management will be work very good, I think. Yeah.
Oh, I see. So there is a wind tunnel across the whole waist, across the whole heart of the onboard.
Yes.
I see. Great. So we will have more information when information of this wind tunnel of the whole diagram for the robot. That's great. So let's work. That is the hardware. I mean hardware components design. The head actuators and the heart and also the heat dissipation. But but we also have an embedded software. So the embedded part and to get it started easily for the onboard. That is more ready to use for developers. So let's walk through what is what RobStride provided. What is your workspace and for embedded and software developers?
Yeah. Okay.
Okay.
Okay. So this part and Wang will help us introduce, and I will give a easy summary as well. Yeah.
So onboard workspace is a pure pattern-based design, so specifically designed for humanoid robot and development test. This environment is structured around the three main models: training, sim-to-sim, and low-level control, and a shared configure layer, providing a seamless workflow from high-level motion strategy learning to real hard work.
Okay.
I see. So that you're providing the first config, training, sim to sim, a low level. So everything is you already provide Python package.
Yeah.
This is great. So that is more ready. It's more ready to use. So but I have one more question for it's ready to use, but usually when we develop now we need a simulation. So I want to know how is your current simulation compatibility to some work stack. I see someone is asking is that are you supporting RSec Sim plus RSec Lab?
Okay, so as Wang said, and as I mentioned before, this onboard is native design with kscale.dev's software platform. So 2 days ago, they just released their open source framework for robots, for robot learning and sim to real transfer structure. Yeah. So which means all the developers can easily get sim to real or sim to sim in 5 minutes with kscale's such a transfer structure. And also, with this structure, it will fully support reinforcement learning with SFG, and we also provide a complete deployment workflow from sim to real hardware. It also supports nonlinear model predictive control based on OSC2, right?
Yeah.
Yeah, OSC2 and rules control. Yeah.
That's great.
Yeah, maybe you can show the
yes, we'll
simulation
have
video.
That simulation video. it's not that one. So this is the you simulated.
Yes,
Okay,
with like SXG, yeah.
Okay, great. I look forward to that when you release that.
Yeah.
When kscale release that, then we will have the full tutorial for ASAC Lab, ASAC Sims.
Yes.
That's great. So, yeah, I think we'll. It's our today's walkthrough for the M-Boat. We haven't make it work because yes, we tried for the policies.
Yeah.
But sometimes it failed. So I hope the next one, we will surely to bring a demo for the working and show the different the action pipelines to we showed in the simulation.
Yeah.
And so we'll have that in the tutorial, and also later we will also working on the other different types of the
Yes.
robots,
Yes.
right? Yeah, because you built a lot of robots, you have actuators.
Yeah.
So yeah, I'm really look forward to working further with RobStride and have other robots. We have we have many questions. I think we should find.
Yeah.
Let's take a look the questions.
Okay.
We will take 2 or 3 questions. So first, as Aximas and Lab, that
Yes,
is
support.
yes, and
The next time you need to be louder. Yeah.
So looks like the CAN bus driver board had 3 wires for each actuator. Are the actuators 3-wire drive? Please provide some detail on the connectivity for these 3 wires.
Okay, so on this board, like maybe.
就是看高、看低和 D。
Okay, so these are 3 port, right? So but normally they are like can high, can low, and G and D. So 3 port.
Oh, I see.
Yeah. Why you guys using this? You just need to connect can high and can low. Yeah. Ignore the G and D port. Yeah.
Okay. So each can port is can high, low, and G and D.
Yes.
Okay. Ground.
And why when we're using like actuators, there will be like 2 types of combination of wires. One is power line, so power high and G and D. This will be connected to the power board, and then the CAN bus will be like CAN high, CAN low will be connected to here. Yeah.
I see. Have you integrated AI to it?
So I think like we need to confirm which kind of AI. So basically all the AI part and the AI algorithm will be developed by kscale Labs.
Yeah, it support. It is it's designed and also compatible with
And
all kscale.
Yeah,
platform.
by the way, and for the controlling, we support like reinforcement learning policy and OSC. This is just like a little bit traditional control algorithm. But for the manipulation, let's looking forward to kscale's new work. Yeah.
So look forward to that. Okay. And also it says there is price. How is the price of that? It is available on kscale website. It's available for state to update. I believe they listed the price. You can go check out. Okay.
Yeah. And by the way, we need to like to check again this will be a very initial version, so it is 3D printed. But for the product and board, maybe launch in the future will be better. Yeah.
Okay, great. Yeah, so thank you, everyone. So this is a sneak peek of the M-Bot and for this hardware and the actuators. So in the future, we'll collaborate more with RobStride Dynamics. And so stay tuned with us for the demo and also more documentation for M-Bot.
Yes.
Here we go.